In this ultimate image optimization crash course, I'm not only going to show you how you can use different file formats and image compression techniques to make an image nearly 10 times as small while still looking almost exactly the same, but I'm also going to show you tips on how you can actually make it so your browser loads different images based on different screen sizes. So you can see as we increase our screen size, this image completely changed. Also, I'm going to show you how we can do lazy loading blur effects. So you can see on the left-hand side, we have this blurry version of the image, and on the right-hand side, we have the fully loaded version, and it'll transition between these two based on how fast the image loads. I'm then even going to show you how you can automate this entire process using a tool like ImageMagick to automatically create these different types of image formats and sizes for you. Welcome back to WebDevSimplified. My name is Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. On the right, you can see we have this quite large image of Yosemite, and on the left-hand side, I have incredibly zoomed in versions of this to compare various different compression as well as file format techniques so we can see exactly the benefits we can get from using different file formats and compression techniques. Now this original file, that's the one that's showing on the left-hand side of VS Code. That is an 8.5 megabyte sized file image, which is absolutely way too big for any browser purposes. Now there's a few reasons it's so big. First, it's completely uncompressed. And secondly, it's nearly 8,000 pixels wide, which is much larger than any image you would use in a real website. But just to show you the basics of compressions, I have 4 different versions of that image on the right-hand side. The very first one that you can see is the comparison here. All I did was take that JPEG image, run it through a compression algorithm to hopefully bring down the size a little bit, and that brought it down from that 8.5 megabytes all the way down to only 5 megabytes. So already you can see we're able to reduce the size by around 40%. But we can actually take that a step further by, instead of using the JPEG format, which is a rather old format, we can use newer formats specifically designed for compression and web-based usage with the format of WebP. WebP is a somewhat newer format that is again focused purely on being smaller than JPEG and better for the web. In our case, we were able to do a compression that actually looks a little bit better when we compare this to this. It's pretty similar, but maybe the WebP is slightly better. And now we're at under 4 megabytes at only 3.5 megabytes. So we're able to shave another 1.5 megabytes off the size of this image. And now we're well under 50% of the size of our original image. But we can actually take that another step by using the AVIF format, which is an even newer version of this WebP kind of style format. This is a newer format that again is meant to even replace WebP, and it's even better at compression. And now if we look at this example, it's actually very difficult to tell the difference between this right side image and the left hand side image. And as you can see, this is incredibly zoomed in, but this right hand side image is only 2.1 megabytes, while the left hand side image is 8.5 megabytes. So we're able to reduce the size of our image down to 25% of the original size while keeping nearly indistinguishable quality between them. And if we wanted, we can go an even further step by compressing this AVIF format even more. By looking at this one, you can see there's noticeable degradation in the quality, but now we're at an image size that's only 1.3 megabytes. So again, it's drastically reduced the size of our image from our original one. But I think this is kind of that sweet spot of 2.1 megabytes. We reduced the size by 75%. Now it's only 25% of the original size. And again, the quality difference between these two is completely negligible, especially when you're looking at a full version of this image. As you can see here, you're really not going to notice those very minute quality differences between the two. Now, unfortunately, browsers don't always support the WebP or the AVIF format. Most browsers will support WebP, but AVIF is quite a bit new and it's only supported in some browsers. But the really nice thing is there's certain features built into HTML that we can utilize that is going to let us load the best image for the person's browser, and we can use tools that will automate the conversion from one JPEG to all these other different formats. So what I'm going to do is I'm actually going to delete all the different compressed and everything images that I have. I'm just going to revert us back to this single original JPEG. And if we just zoom this back out to the full size, you can see this is the JPEG that we're working with. And in order to do these conversions, I could just go online and Google JPEG compressor and WebP converter, and I could drag and drop my file up there, do the conversion, and then download the resulting file. But the downsides of doing this is it's a manual process, and I may not get the exact quality and conversion that I want. This is why we're actually going to be using a tool called ImageMagick. You can download it however you want. If you just go to the ImageMagick site, which is ImageMagick with a K at the end, .org, that's going to allow you to download this tool to be able to use on the command line. It's very similar to FFmpeg if you've used that before, but it's specifically for dealing with images. In our case, we can do these conversions for us. So all you need to do is type in magic, again with a K at the end, type in the input image you have, which in our case is input or image.jpg. Then we use this dash quality flag, which determines how much compression we want. 100 is essentially no compression at all. It's the best quality you can get, while something like 0 would be so compressed you wouldn't even be able to tell what you're looking at. Now, depending on the actual file type you're using, you can change around this compression number however you want. But in our case, if we're going to be using a JPEG image, something like 75 is going to give you a pretty good quality, and that's what I used in that initial comparison. Then we can give this any name that we want, for example, image_compressed.jpg, and that's going to go through and it's going to compress our image. And by doing that, again, we now have a 5 megabyte image as opposed to an 8.5 megabyte image. And again, the quality comparison we already looked at, they're pretty much indistinguishable from one another. And the nice thing is you can run this exact same command for converting to a different file type. So I can take my same input and my same quality, and now I can change to doing WebP instead. And the nice thing is, since WebP is actually better at compression, we can lower this quality number down to like maybe 70, for example, and it'll still look pretty much identical. So if we do that, now we give it a second to run. It may take a little while depending on the power and speed of your computer, but once that's done, we're now going to have an image compressed WebP. And here we go, we have that file, again, pretty much indistinguishable from the other ones, but this is only 3.6 megabytes, so drastically reduced in size. We can do the exact same thing for AVIF, but the nice thing is, again, this is also much more performant at compression, so we can drop all the way down to 50, and it's going to look pretty much identical to the original image. It's actually going to look better than the WebP and the JPEG compressed version, even though it's more compressed than those other two file types. And this is going to give us that AVIF format, and here we're only at 2.1 megabytes, which is that high quality compression I showed you at the beginning, where they were pretty much indistinguishable from the much larger image size we were talking about. So this is a really great way to automate this process. You could set up a script file that automatically goes through all your files and converts them to these compressed formats for you to use inside of the web. Now, once we have all that compression done, the very next step is to use that inside of our browser. Right now, the way that we're loading our image is just using a basic image tag, which is fine if you have just one image you want to load, but what happens if you want to load different images based on the user's browser support? Like I said, some browsers support AVIF, most support WebP, and everything is going to support JPEG. So I essentially want to use the best format possible for the user's browser. This is where the picture tag comes in. With the picture tag, it works like an image tag, but allows you to pass in various different sources. So let's get our picture tag just like this. And by default, you just want to put whatever your fallback image is. So our image for the just normal JPEG, that's our fallback. So we're going to put that inside our picture tag. If we save, on the right-hand side, you'll notice absolutely nothing changes. Our image loads just fine. But now we can specify alternative sources that are going to load if the browser supports them. So all we need to do is come in here with the source attribute, just like that. It's a self-closing tag. We need to specify the source set, and that's going to be the path to our image. So we have our image compressed.webp. That's going to be for our WebP format. And we also need to specify a type. And this type essentially specifies what type of image is this. Well, it is an image/WebP format. So now we know we should be loading the WebP format if we have that accessibility in the browser. And if I actually inspect our page, I bring this over and we look at our network tab, and we're just going to make sure that we have no throttling, and we're going to look at just our images. Now you'll notice the image being downloaded is that WebP version because our browser currently supports the WebP format. So it sees the WebP version and downloads that because it's a much smaller and easier to work with file size. I can do the exact same thing for AVIF. So change our file to AVIF, and for our image type, AVIF is going to be the type. And now the way your browser actually works is it starts at the first source and says, do I support this type right here? If so, download the image in the source set and use that. Otherwise, if this type is not supported, it'll skip down to the next one, check to see if that type is supported. If it is, it'll use the image, and it'll do that all the way down until it gets to the very bottom. You can almost think about it as like a really big if-else statement. So now if I save and we actually inspect and we look at our network tab, you'll notice we're downloading that AVIF format for our file because that is what is being supported. Now, if I were to change this to some made-up file type that is not supported by our browser, you'll see it skips this one completely and will move on to this WebP version. So if we inspect and go to the network tab, you'll notice here we get the WebP version because the first one is not supported, so it's completely skipped. So depending on what browser you're using, it'll either skip or download certain files, and it'll give you whichever one's the best one. And again, it always goes from top to bottom, so whichever file is the best for you, put that at the very top, and the worst case scenario, put at the very bottom inside this image tag. That's like your fallback for if none of the other sources work at all. Now, the next best way to make our images smaller is just by reducing the size of them. Like I said, this image is like 8,000 pixels wide, way wider than you would ever need for a realistic image. So we can use the exact same ImageMagick command line tool to actually resize these images to be much smaller. So to do that is rather simple. Let's just clear this out. We need to type in that magic command again. We type it in whatever our image we want to work with is. I'm just going to use the base image for now to show you the differences. We can use the -resize flag, and then you can specify what the width is going to be. And usually you just want it to automatically scale. So you only specify the width and the height will automatically resize to maintain your aspect ratio. Let's say for this images, we wanted it to be 500 pixels wide. We would type out 500. Then you put an X with nothing after that, and that specifies the height is automatic. You could force the height to be a specific size by typing that in yourself, but by just leaving it off, it'll automatically resize the height based on this brand new width. You can also put a little greater than symbol here, and that means your image will only ever shrink down. Currently, if my image was only 400 pixels wide, this command without the greater than symbol would raise the size to 400 or 500 pixels. In our case, we never want to increase the size of our image, so we'll always put this greater than symbol, which will force it to always get smaller. Then we could just say image resized, for example, .jpeg, and this is going to resize and shrink our image down, and we could even combine that together with that quality flag we used earlier to resize and shrink our image at the exact same time. Now, the last thing to make this actually work properly is just to wrap this 500x section inside of quotes. That way Windows doesn't assume that this greater than symbol is for piping stuff around. It'll just make everything work properly. Now, if I let that run real quick, that'll actually resize my image for me. And if I go ahead and I open up that resized image, it is now 500 pixels wide, and you can see it's now only 50 kilobytes instead of 8.5 megabytes. So it's drastically reduced in size, and you can see it is a much smaller image. And if we were to actually use that image inside of our index.html, we'll just comment out this picture for now and just load specifically that new resized image, just like that. You can now see over here, currently it looks a little bit blurry because my image is currently much wider than 500 pixels, but it kind of gives you an idea of what we're talking about. Also, taking such a large image and resizing it to be drastically smaller like we've done, again, may add some of that blur into that particular image. But in this case, you can resize the images to be whatever size you need them to be to fit directly inside of your browser window. Now, obviously, shrinking down the size of your images is great, but one thing that doesn't work great is that on larger screen sizes, these images are going to look blurry, kind of like this one does, and on smaller screen sizes, these images are often going to be larger than they actually need to be. It would really be best if we could create like 3 or 4 different sizes of each image. That way, depending on what screen size the user's on, they can load either a really small image or a larger image to get that best experience. That way, the mobile user only downloads a small image, so it's quicker for them, and the desktop user can download a much larger image because they have a much larger screen. Luckily, that's actually something we can do inside of HTML with the normal image tag, and we're using this source set property specifically for that. So we can come in here with a source set, and we can essentially set this to a comma separated list of all of our images and the sizes we want to use. Now, I generally like to put these on a different line so it's a little bit easier to read, and I'm going to be using a placeholder image site just to make it a little bit clearer exactly what's going on. So we're actually going to be using a site called placehold.co, and you can specify the width and height of an image, for example, 800 by 200, and the file type PNG. That's going to give us an 800 by 200 pixel PNG image. Then after that, we can specify the width of what this image is going to be. So we can say 800W is an 800 pixel width. So what we're saying is on a screen size of 800 pixels and smaller, we want to use this image that's 800 by 200 pixels. We can then specify a brand new entry. For example, this one is going to be for double the size. It's going to be 1600 by 400, and that's going to be on a 1600 width screen. Then finally, we can come in here with an even larger image. Let's say this one's going to be 3200 by 800, and that's going to be on a 3200 pixel screen. So now I've essentially created this section where I'm using a small image on smaller screens, a medium image on medium screens, and a large image on larger screens. So you can see when I increase the size of my screen, when I get to the point of that 3200 pixel image, it's going to load in that much larger image. But the key is when I shrink my screen back down to a smaller size, you can see it stays with that larger image. Essentially what happens is whatever the largest image the browser currently has downloaded, that's the one that it's going to be using. And on really small screen sizes, it'll download the smallest possible image, while on larger screen sizes, it'll need to download these larger images. So this is a great way to make it so that on small screen sizes, you're using a small image, and on large screen sizes, you're using a large image. And even if the user resizes their browser, it'll properly go off and get the new larger image and bring that down so we can use that for the user. Now, one thing you'll actually notice that's quite interesting about this, if we do a quick hard refresh, that'll get us back our initial image. And when I increase the size of my browser, the actual point where I go from a 1600 pixel to a 3200 pixel image is a little bit interesting. We're going to inspect our browser at this exact point, and you'll notice that at this point, my screen is 1300 pixels wide. And we just swapped from a 1600 pixel image to a 3200 pixel image. You may think that swap should happen at 1600 pixels because now at 1601 pixels, my screen is too large for a 1600 pixel image, so it swaps over to the larger 3200 pixel size. But we're actually converting rather early on my particular screen. The main reason that this is happening is because of a device pixel. If we go over to our console, we can just type in here device pixel ratio, and you'll notice on my screen that device pixel ratio is set to 1.25. That means every single CSS pixel corresponds to 1.25 pixels on my actual screen itself. This means if I want to render an image that is 1600 pixels wide, it's essentially going to divide that by 1.25, and that's the actual width of my screen that'll be rendering out that image to the user. Now, most of the time, this is going to be a 1-to-1 ratio, but if someone has their entire desktop zoomed in like I do, or if you're using a phone, often they have a higher pixel ratio than 1-to-1, you're going to see this particular scenario come out. For the most part, you don't really have to worry about it though, because behind the scenes, the browser handles everything for you. It's going to see, hey, at this point, we're going to need to render the larger image, and it's just going to render that automatically for you. So you don't have to worry about all these different device pixels and everything like that. You just know it's going to render the proper size image for you automatically. Now, another important thing to realize is that this source attribute's not actually being used. That's because by default, if you use source set, this source is completely ignored. The only time this source is used is if for some reason the browser you're using does not support source set. But source set has been around in browsers for 10 plus years, so it should be supported in every major browser. But just in case for a fallback, I always take the largest image size that I have, and I replace whatever the source is up here with that larger image size. Now, another really nice thing is since this is a source set property, we can actually use this directly in our picture element. For example, here where I have my source set to load that image, I could replace it with whatever source set I want. For example, if I had 3 different levels of this compressed AVIF format at 3 different screen size resolutions, I could use each of those different screen sizes here. So now it's able to compress my image even further. So essentially, I've gone from the large uncompressed image to now using a compressed image and also properly using the correct size image. And this is able to reduce the size of the image rendered to my screen by 50% in the worst case scenario, all the way to maybe even 20 or 10% of the original size of the image, because we're now rendering a much smaller image and we're rendering in a much more performant and higher compressed version of that type of image by using AVIF or WebP. Now, oftentimes your images are not going to be the full width of your screen. If they are, this source set property with this width works perfectly fine, but sometimes you're going to have it contained inside of another object, which is where a brand new property called sizes comes in. I'm going to comment out this picture element just so we can focus on one image at a time. And we're going to come in here with this sizes property. And this allows us to essentially write media queries to contain what the size of our image is going to be, essentially to contain what this value compares against. By default, this is set to 100 VW. That just means compare whatever this pixel value is to 100% of the width of the screen. Pretty straightforward. But we can modify this. For example, I could hard code this to be 800 pixels, and now it's always going to be essentially comparing as if my screen size was 800 pixels. I could change it to 500 pixels, and now it's hard coded to comparing against 500 pixels. And when I refresh my page with a hard refresh, you can see we get that smaller image size, even though our screen size is technically larger than that 800 pixels we have. So normally what you're going to want to do is you're going to want to fall back to maybe that 100 VW result if your image is full screen, or if you have a maximum size of your image, you can put that in here as well. So generally what I like to do is let's say that the maximum size my image can be is 800 pixels. We'll actually wrap it inside a div that's going to do that for us. We'll come in here and we'll say style, and we're going to say that the max width of this is going to be 800 pixels. Actually, let's do 1200 pixels. There we go. So now we have a 1200 pixel maximum width that we can have on our container, so it can never get larger than that particular size. So if we increase our screen size, you can see eventually when we get to 1200 pixels, it's no longer able to increase that size of our screen any further. And actually, let's make that a little bit smaller. We'll make it 600 pixels, and hopefully that'll be able to give us essentially a variety of different image sizes that we can go around and play with. So now what we can do inside of our sizes section is we can specify our media queries. So we can say, for example, maximum width, and this is going to be a maximum width of 600 pixels because that's our max size. In that case, our image is essentially the full size of our screen, so we'll use that 100 VW. If we're not in that maximum width though, we're going to fall back to a default value of 600 pixels. So essentially we're saying when our screen is less than 600 pixels, use 100% of the screen size. Otherwise, use a maximum screen size of 600 pixels. So now if we just do a hard refresh and we increase the size of our page, you'll notice it actually never changes what image we're using because 600 pixels is small enough, it never jumps up to this next size image. If we were to change this to 1000 pixels, and 1000 pixels, and here also 1000 pixels, we now should see that our image, as we get to a certain size, will jump to 1600, but you can see even if our screen is very large, it never jumps to that 3200 pixel image because it never gets big enough to jump past that 1600 pixel barrier. So this is a great way to constrain what your actual image size is going to be based on different media queries. And you can actually combine together multiple media queries. For example, I can come in here with a second media query. And for example, this one could say 500 pixels. Then we're going to be using some other comparison value, whatever it is. Then if it's less than 1000 pixels, use this value. And then finally fall back to a hard-coded value of 1000 pixels. This is again mostly useful when you have an image that is constrained in possible size. This is very common because most of the time your site is not infinitely wide, it has a maximum width, and this is going to be a great way to constrain things within that maximum width so they don't grow out of proportion to be too large. Now the nice thing about this sizes property as well as the source set property on the image is that everything's automatic, and the great thing is for example, if I'm on a smaller screen size and it has that smaller image rendered, and I eventually load a larger image, it'll just keep that larger image loaded all the time, which is great because now I have that larger image showing up and I don't have to constantly swap between images doing a bunch of extra downloads. But sometimes based on artistic ability, you may want to render a completely different image on small screens versus large screens because for some reason, maybe your focus on the image is in a different spot based on the screen size you're working on. In that case, swapping from an actual image to a picture element is going to be great, and we can actually look at the media query directly inside of here. So instead of bothering with type, we're going to swap to be using a media version instead, and you can combine these together so I could have a type and a media query and a bunch of different comparisons. But for our case, we're going to do really simply just a source set here that's going to render a specific image. We'll call this our image compressed .avif. So we have that avif version. And here I can come in with a media query. And this works just like my media queries down below. Let's say in this case, I want to have a max width of 500 pixels. So I would write out max width of 500 pixels. And now when my screen is 500 pixels or less, it'll use this image. Otherwise, it'll fall back to this image here. And to show us what that looks like, let's just come over here with an 800 pixel image right there. And we'll say when our screen is 800 pixels or less, it's going to use this image. Otherwise, it'll use the full size image. So here we have that 800 pixel image. And on a larger screen size, it pops over to this image. But the important thing is when I shrink back down my screen size, it pops over back to the smaller version. So this media query section on my source allows me to actually swap in and out different images based on actually what I want to render on my screen. And again, this is really useful because, for example, on a large screen size, this image may be too much, but you maybe want to crop the image to only render, for example, this right-hand side on a small screen size. So you can render a completely different cropped down image on the small screen size while you render the full size image on the large screen size. And you may think, well, we have like background cover and object cover inside of CSS to make sure it crops down the image for you. But the problem with using those techniques is it still loads the full size image. It doesn't load just a cropped version. So by creating a completely separate cropped smaller image and loading that using this media query tag, we're able to load just that smaller section of the image instead of loading the full image and then cropping it down later, again, saving the user the extra bandwidth of having to download a larger image than they actually need. Now, the next thing I want to talk about is going to be how we lazy load images. So to make this really easy to work with, I'm just going to simplify our code down to a single image. And this image, I'm going to get rid of all the sizes and everything. And all we're going to do is have a source directly inside this image. And we are going to load a bunch of different images on our page. So what I can do is I can just paste down some code for a bunch of images. You can see here we're loading a ton of different images. And if we inspect our page, go over to the network tab and we refresh, you can see it's currently loading 17 different images, which are all these images on our page. But we don't need to be loading the images all the way at the bottom of the page while we're at the top of the page because that's just not very performant because those images aren't going to be seen right away. This is where the whole idea of lazy loading images comes in. We can come in here and we can specify a loading property and we can set that to lazy. And what that's going to do is it's going to tell the browser to only download this image if it's actually going to be needed to render. So we can put that on every single one of our different properties, just like this. Now all of our images have that lazy loading attribute on them. And if I inspect our page, go to the network tab and refresh, you'll notice it's still loading all of our different images. The reason for that is because by default, our images have a height of 0. So essentially all the images show up on the screen at one time. We could easily fix this by putting a specific height and width on our image, which is generally something you want to do if you know the height and width ahead of time. So inside of our styles CSS here, we'll just specify a minimum height of 500 pixels, which forces all of our images to be at least 500 pixels tall. That'll help space out our images from each other so they don't all appear all at once on the screen. And now if we go to our network tab and we refresh, you'll see we're actually only loading 5 images at a time. And as we scroll down our page, you'll notice more and more requests are being added. Now we're at 9 total images, now we're at 12. And when we get to the very bottom of our page, we'll be at that full 17 different images being rendered. So this allows us to actually render the images on our page only when they're actually loaded on the page. And as long as your page isn't just full of images like ours is, you don't really even need to worry about this trick of setting a height or anything like that, because there's going to be a lot of text and other content between your different images. This is one really easy, quick, and simple performance attribute to make your page load faster because there's less things that need to get downloaded. Now to talk about adding in some blurry, lazy loading, I want to just bring us down to one single image. And what we can do is we can slow down our network speed in that network tab. And instead of having no throttling, I'm going to set this to slow 3G, just to really slow down. Actually, we'll just set it to normal 3G now to see if that's quick enough for us. And what we can do is we can refresh our page, and you'll notice that there's essentially going to be a blank box at the top of our page where our image is loading in. You can see we just have this blank rectangle right there. That's because our image doesn't have a specific height or width loaded for this image yet, but we just had that blank rectangle showing up on our application, that white line. That's because we were waiting for our image to load, and then our image finally loaded in. To make it a little bit easier to see what's going on, let's come in here with a style, and we're just going to say width is going to be 700 pixels, and our height is going to be 700 pixels because we know the size of our image. And now when we refresh our page, you'll see we essentially get a white rectangle because I have a border around our image. That's where our image should be. Now by default, a JPEG image is going to load from top to bottom. Just to show you what that looks like, we can use our compressed JPEG image, and you'll really easily be able to see that it is loading from top to bottom. As you can see, each individual segment is slowly loading in from the top to bottom. Now, this is something we can actually get around by using a progressive JPEG. So what we can use is we can use that ImageMagick command, and we can say our input image, which we'll just say image.jpg. Actually, we'll use the compressed version. Doesn't really matter. There we go. Then the next thing that we want to do is we want to add these interlace property, and we can set that to plain. Essentially, that's the property we need to set to actually make this a progressive JPEG. And then we can say what our output is going to be. We'll call this one progressive.jpg, just like that. So now we're converting this JPEG to a progressive JPEG, which will load in a more and more essentially detailed version as we go. So let's change this to our progressive JPEG. We're going to refresh our page over on the right-hand side, and we should now see, instead of from loading from top to bottom, it's going to slowly load in a less and less, or a more and more detailed version as we go. So you can see here, it's at least going a little bit quicker and loading that from top to bottom just because it's a very large image. But then once it's done loading from top to bottom, it should hopefully giving us a more and more detailed version as we go. Now to really showcase that it is actually progressively enhancing this image with a better and better detailed version, let's do another refresh of our page. I'll bring over our network tab, and you'll notice inside of here we get the image itself, and it's going to be slowly downloading that image, as you can see by this bar right here showing us we're downloading it. Now the actual rendering of our first pass of the image from top to bottom is significantly quicker because essentially it only needs to render a lower quality version, the first little bit of the image. Then you can see it's still downloading the image in the background because it's essentially downloading more and more layers to add on top of the image to give it more and more depth and detail. So this is kind of how JPEG gets around the fact that the images are quite large. It essentially allows you to load a smaller version with this progressive ability. Now, AVIF and WebP don't have this progressive rendering format in them, but since the file sizes are so much smaller, it's not really a big deal. And the technique I'm going to show you doesn't even depend on this progressive feature, but this is a nice thing when you do your compressing of your images. Make sure you compress the JPEGs as progressive just to get a little bit quicker load for your user. Now to do this blur effect, it's actually much easier than you think. All we need to do is, again, open up ImageMagick to do this for us. And we're going to come in here with Magic. We want to take our input image. Again, it doesn't really matter which one we use. We'll just use our normal JPEG image. And we're going to drastically reduce the size of this image using that resize property. And instead of reducing it to like 500 pixels or something like that, we're going to reduce it to literally only 20 pixels. So we're going to use 20 pixels as the size that we want this to be. And we're going to change this to image-blur.jpg, just so we have that ability to reference that image. And again, you could use AVIF or whatever if you want, but since this image is so small, it probably doesn't even matter what image format you use. If we actually open up that blur image, we are at 3.5 kilobytes. And as you can see, this image is incredibly small and incredibly blurry. But the nice thing is when we render this inside the browser, it's essentially going to give us a blurry version of our image. Instead of being pixelated like this, it'll smooth that out and give us a blurry placeholder image we can use while the rest of our image is loading. And to create this is actually super simple. What we can do is we're just add a class name on here. We're going to call this class name blur, just like that. And then in our styles, let's add some styles for blur. The first thing we're going to need to do is have a background URL. So we're going to come in here, which our background, and we'll make this an image. And this is going to have a URL, and that's going to point to that image blur.jpg. Make sure I spell all that property. There we go. So now our background is just going to be that image blur. So while it's loading in whatever our particular image is, you can see it's rendering out that blurry version of the image before it renders out the full image. Now again, we'll make sure we have our network tab open for throttling purposes. So when I refresh, it will throttle my page, and that blurry version of the image should load pretty much immediately. But you'll notice it's essentially tiled across like this, which is not what we want. Instead, we want it to load just that blurry version as a full size image. So we can come in here with background repeat. We can set that to no repeat. And we can also come in here with a background size and set that to cover to force it to fill the entire size of the space that it has. And now when we do a refresh of our page, it'll take that really small 20 pixel image and blow it up to be the full size of whatever our image is supposed to take up. And you can see it gives us a nice blurry effect for our image. And already that gives us a decent fallback for our image. You can see we get that blurry version and then it slowly loads in the real version over top. But oftentimes you may not want that slow loading over top, or you may just want to have like waiting until you get the full detailed version of the image and then pop it in over top of that blurry version. So we can take this simple CSS and enhance it even further. The first thing we can do is instead of putting our blur class directly on our image, we can wrap our image inside a div that's going to do that for us. So we can just move that class up to our div up here. And I'm also going to move our style up there as well. There we go. So now we can get rid of this entire section. So now our image is essentially inside of this 700 by 700 pixel div that has that blur class being applied to it. Now you can see we are still getting that blurry image showing up, which is exactly what we want. And the other image is loading over top of it. Now for our particular case, we don't actually want the image itself to show up until it is fully loaded. So we're just going to come in here and set an opacity of 0 on our image. So our image is always not going to show up at all. And instead is just going to show us that blurry image instead. Now you will notice we're getting a small issue with the actual aspect ratio of our image. Essentially, I'm determining an aspect ratio of 1:1. Our image doesn't technically have that aspect ratio. To fix this problem, we'll just remove the height aspect from here. Again, you would know the actual width and height of your images if you're hard coding this, but for now, I'll just leave that off and we'll just put a width of 700. So the aspect ratio of my image is entirely maintained, which is perfect. So now we have that blurry version, but our image is just not showing up on the screen because we have that opacity set to 0. We can even take our blurry image and add a step further to add like a little nice blur effect to it. So we can say .blur, and what I want to do is I want to get the before attribute on it, add some content, position absolute, inset 0, which means it fills the full container, and it's going to have a background color of white, and we're just going to pulse between a 0% and a 10% opacity. And by doing that, if we just give our page a quick refresh here, you can see we kind of get this effect where you can see that very small white pulsing effect on our page. This looks really good for when we have like a loading state for our image, so the user knows, hey, this thing is currently loading. You can change around this loading state to be whatever you want, but I find that this looks relatively good and is not super intrusive.
As I was editing this, I noticed one small problem. You'll notice that this pulsing animation actually leaks outside of its container. That's because we just need to make sure on our blur class that we put a position of relative, and that'll make sure to contain that pulse animation.
Now the final thing we need to do is determine when our image is loaded so that we can hide this blurry state and actually show the state that we care about. So I can come in here and I can say .blur, and what I want to do is I want to say when this is loaded, I want to get my before element, and I want to say that the animation is going to be none because I just want to remove that animation completely. And I also want to say the content here is going to be none because I want to completely remove that before element. So as soon as my image is loaded, we'll add that loaded class so that this never shows up. Then the next thing that we can do is we can take our blur, and what I want to do is if it is loaded, I want to select my image, and I want to set the opacity of my image to 1. And then finally, all the way up here where we select our image, we can just add a simple transition. So we have a nice animation that transitions our opacity over 250 milliseconds with an ease in out. So we just have, again, a really nice transition between our image when it's loaded from that blurry state. It's just going to fade in perfectly over that blurred version. So now what we need to do is determine when our image is fully loaded on our page. To do that, we're going to need some JavaScript. So let's just come in here with a script.js file. Make sure we load that in our HTML. So we can say script, defer that just like that. There we go. So now we have this script file being loaded. And inside of here, all we would need to do is select that blurry div. So we'll just call this blur div. That's just document.query selector. And we want to get the thing that has that blur class. Obviously, if you had multiple images with this blur showing up, you would need to query selector all and loop over them. But I'm making this pretty simple. We can also get the image by selecting that blur div, and we want to query selector the image directly inside of it. So now we have our blurry div as well as our image. For our image, we can essentially just wait to see if it's loaded or not. So we can use the complete property. This is true if our image is loaded. So if our image is loaded, then we want to call some function. I'll call this loaded. And this is going to set up all of our classes for us. So what I can do inside of here is I can take my blur div class list, and I can essentially add that class list of loaded. There we go. So if our image is already loaded by the time our JavaScript renders, it'll just add that loaded class. More often than not, though, the image is not going to be loaded. So we're going to need to add an event listener to wait for that load event, and then we'll call that loaded function. So we either automatically add it if our image is currently loaded, or we wait for our image to finish be loading, and we add that loaded class to it. just by doing that should actually fix all the problems inside of our image loading related content. Now, if we give that a quick second and we go over to our HTML, you can see right now it has that nice pulsing loading effect, and it's going to be downloading our image in the background. Now, this might take a very long time because we're on a very slow network connection, but if I come over here and I were to speed up by removing the throttling, you'll notice immediately once it finishes downloading, it fades the full image in place, and essentially that background image that was there is completely removed. So this is a really easy way for you to just add in that blurry effect without too much work or too much extra resources being downloaded, because again, that blurry image is only a couple kilobytes at most. And if you're worried about how big this image is, you could do extra compression to make it even smaller by using that quality attribute, or you could even make it a smaller image than 20 pixels, but I find 20 pixels works relatively well. Now, there's a ton of different features we covered related to image optimization, and you can use as many or as little as you want. If all you care about is a nice cool blur animation, you can add in this blur code. Or if you want to go all out, you can use picture with a bunch of different source sets for different media queries and different sizes with different image formats and sizes to make your image exactly perfect for the user, to make it so they download the least amount of image sizes as possible, to make it as quick as possible for them to load the page.